Hello folks, in today's video we will learn the basics of object-oriented programming in Java. So we will first learn about constructors and then we will take a quick look at the four fundamental concepts of object-oriented programming, and that is polymorphism, encapsulation, inheritance and abstraction. So let's get started. Hello folks, in this video we will learn about constructors in Java. So constructors are a type of method that gets called when the object of a class is created. And to understand that, let me create another class over here. So I will name this class as Pokemon, and here first of all I'll declare one name. This is the Pokemon name, and also the type, and also the generation of the Pokemon. And now I will write one function. Let's name this display info, and this will simply display the Pokemon info. So let me write system.out.println, and let's write Pokemon info displayed. And after this, let's display the actual info. So I will here write name of this Pokemon is, and I will write the name, and then the same for the type and everything else. So I will simply copy these two lines and remove these two, and here we will have type, and here I'll have gen. Let's also change it here, type and gen. So now in my main function I will remove this hello world, it's not required, and here I will create an object of Pokemon. So let's name the object as Eevee, and here I will write new Pokemon. So this function that you are seeing over here, this is called a constructor. Now inside the Pokemon class we have not written any constructor, so this will create one non-parameterized constructor by default. We will say this one. So now let me try to invoke this display info function from the main method. So I will simply write ev.displayInfo, and let's see what we get. So let's run this function by clicking on this triangle button, and what we are getting is Pokemon info display. So it's going inside this function, and then we are getting name of this Pokemon is null, type is null, and gen is 0. So, and that is because we don't have any value assigned to name, type and gen, and this is something we can do with a non-parameterized constructor. So what is a constructor? So constructor is a method that will have the same name as the class, and this doesn't have any parameters. So this is called non-parameterized constructor. Let's write cons. And here first of all let me simply do one system.out.println, and here what I'll write is non-parameterized constructor called cons called. That's it. And next things we will do is we will assign some values to the name, type and gen. So let's assign the name as Eevee, and Eevee is a normal type Pokemon, so I'll write normal, and then Eevee is from generation 1, so I'll write 1. Now if I simply run the same function again, that is ev.displayInfo, what do we get? So we are getting non-parameterized constructor called, then we are getting all of these things, and we are also getting the values. Now one thing to note here is, if I even comment out this line, we will still get this first line, non-parameterized constructor called, and when we click on run we are getting this non-parameterized constructor called. So this line is getting invoked only in this line only. So whenever we are creating this object, it is going inside this constructor and it is creating, it is like printing this line. So this is how constructor works. Now there are two more types of constructors. So you can consider constructors to be the methods that is actually constructing this whole object. Now this is an example of non-parameterized, but we can also pass parameters. So now let's get an example of parameterized constructors. Parameterized cons, and I will write Pokemon, and here I have to pass some parameters. So what are the parameters? The parameters are these three only. So I will pass one string of name, and then I will pass one string of type, and then I will pass one int of gen. That's it. And inside, what I'll do is I will simply print out one line like this, and I will write parameterized constructor called, and after this I will simply assign in this dot name, I will assign this name. So what this dot name is, it is this means it is referring to this object, the current object, and here I want to assign the name that I'm passing as a parameter. And similarly for this dot type, I will assign type, and for this dot gen, I will assign my gen. So how can we call this constructor? So now if I simply run this method, what do we get? We are getting non-parameterized constructor called, because this ev over here, it is invoking this method, and this method is actually this method, which is a non-parameterized constructor. So to invoke this method, I have to create an object and then pass some parameters. So let me create another Pokemon, and let's create Latias. So here I will write new Pokemon, and here I will pass the required parameters. So the first parameter is the name, so that is my Latias, and then the type I believe is dragon type, and then the generation is, I believe, generation 3. It's from Hoenn region. So yeah, now what I'll do is now even if I invoke this method right here, I will get that parameterized constructor called, but I'm not displaying the info, so I can simply do Latias dot display info, and then I will also be getting all the info, and we are getting it that Pokemon info display, name of this Pokemon is Latias, type of this Pokemon is dragon, and generation is 3. Yeah. Now the third type of constructor that we will check is called the copy constructor, and what this does is it only makes the copy of one constructor of like basically one object. So I can simply write Pokemon, and inside I will pass one object of Pokemon, and let's name it Pokemon, PKMN, Pokemon, the short form. And what I can simply do over here is first of all I will again like do this thing to know that this constructor is getting called. So I will write copy constructor is getting called, and what I'll do over here is I will assign the info of Pokemon to the current object. So what I'll do is I will write this dot name equals to Pokemon dot name, and this dot type equals to my Pokemon dot type, and then this dot gen equals to my Pokemon dot gen. And now to invoke this copy constructor, I have to create another object. Let's name it Pokemon Latios, and here what I'll do is I will simply pass my Latias. The name will be wrong, but the other things are correct, so I can do this thing. And now if I run, you will see that in this line I'm getting that copy constructor is called, and I can also display the info. So I will write Latios dot display info, and that's it. I'm running again, and we are getting everything: non-parameterized constructor called, parameterized constructor called, copy constructor called, and all the necessary info. So this is the basic funda of constructors in Java. So that's it for this video. Thanks for watching, and bye bye. Hello folks. In this video, we will learn about one of the 4 essential object-oriented programming concepts, polymorphism. So polymorphism means when one function can be executed in a variety of ways depending on the object it is working on. And to demonstrate that, I will first of all create another class. I will name this class as Pokemon region, and inside this class I will have one string region and one int generation. Now I will also write one function public void info, and here I will pass the region as a parameter, and I will simply do south, and I will write this is the whatever is my region. Now I will come back to my main method. I will remove this hello Pokemon world, and I will create one object of this Pokemon region. Let's name the object as Hoenn equals to new Pokemon region, And now I will assign values to the region and generation. So hoen dot region equals to hoen, and hoen is the generation 3, so hoen dot gen equals to 3. And now I can also invoke this info method, so I can simply do hoen dot info, and here I have to pass the argument, so I will simply pass hoen dot region. So now if I run this program, what will the answer be? So let's see. So we are getting this is the hoen region, and that means this void info, this function is getting executed. Now what happens if I write few more functions of the same name? So I will write public void info, and instead of the region I will pass the generation as a parameter, and I will create another function of the same name once again, public void info, and this time I will pass both the parameters. So I will pass the region as well as the generation. And now inside the second function I will simply print out this is Pokemon generation and whatever is the generation. And in the third function I will simply do south. This is the whatever is the region, and then whatever is the generation of Pokemon generation, and then the generation. Now what happens when I run this program? So what function will it call? Let's see. So it's running and this is calling, this is the hoen region. That means inside my Pokemon region class this function is getting executed, and these two functions are simply ignored. Now why is this happening? So this is also something that we call method overloading, and this is something that happens in compile time. So what happens is when the compiler is compiling this program, it is reading all these functions and it is differentiating the functions based on the arguments or parameters. So it's saying that this is taking the argument as the region, and this is taking the generation, and this is taking both. So these three functions have at least one differentiating factor, so these three functions must be different and should be called accordingly. Now instead of the parameters there could be other differentiating factors also, for example the return type. So all of these three functions have void return type, but one of them could have an int return type, and that means that function is different. So this is how it is differentiating the function like the functions, and we can also access them accordingly. So the second function we can write something hoen.info, and here I can pass the generation, and I can also invoke the third one. So I will write hoen.info and I will pass both, so the hoen.region and also my hoen.generation. Now if I run, I will see that I am getting the results accordingly. So I am getting that all these three functions are getting executed, and this is also what we call polymorphism. So one function info is being executed in three different ways based on some differentiating factor. So here the differentiating factor is basically my argument. So this is how polymorphism works, but this is only compile time polymorphism. Now there is also something that is called runtime polymorphism, and that is something we will see now. So let's say after the info function I am creating another function, and let's name this function as attack, and here I will simply do south and I will write Pokemon attacked. Now as you know, I can also access this function, so I will simply write hoen.attack and let me execute, and I'm getting Pokemon attacked at the end. Now what happens if this function has some, like this class has some subclasses? So I will simply write two more classes, Latias. Like this is a part of inheritance, but for checking out like runtime polymorphism we have to check it like this only. So this Latias is a subclass of the Pokemon region, and here inside I will have a name. So I have a string name, and here I will write the same function public void attack, and here I will do a difference out. So I will write whatever is the name use, and I will write the signature move of this Pokemon, and I have not yet sent this Pokemon. So this is Latias, and the signature move of Latias is Mist Ball. And then I will also create another function let's write it only. Class Latios extends Pokemon region, and here I will again have the string of name, and then I will have the same function public void attack, and here I will simply write name, that is Latios, use the signature move, and the signature move is Luster Purge. I believe one raises falls the special attack then, and the other the special defense, whatever is that. So now in my main method I will simply create two more objects of this Latias and Latios class, and we will see what happens. So right now if I execute, only the Pokemon attack from the Pokemon region class will be executed. Now how can we actually execute these methods? So let's do one thing. Let's comment out this line and create one Latias equals to my new Latias, and also let's create an object of the Latios class equals to new Latios. Then let's assign the names. Latias dot name equals to Latias, and Latios dot name equals to Latios, and then we can simply execute. So let's do one thing, Latias dot attack. Now what will happen? So we have commented out this line, and when we are doing Latias dot attack, we are getting Latias use miss ball, and we are really not getting this one, that is Pokemon attacked. Now what we can see over here is this, all of these three attacks, they are exactly the same. There is no differentiating factor. So this is what happens in the runtime, and this is what we call method overriding. Method overriding, and this is a runtime activity. So in the runtime it will see that whatever object, which object is calling it, and depending on that it will execute accordingly. So if I do Latias dot attack, it will do the same, and if I do Latias dot attack, it will execute accordingly. So if I now run, we can see both Latias used missed ball and Latios used Luster Purge. So it knows when to call which function. So whenever an object of the Latias class is calling it, it is running this attack function, and whenever one object of the Latios class is calling, it is calling this attack function. Now we can also uncomment the who dot attack, and it will run accordingly. So let's run again and let's see the result. So we can see Pokemon attack. So when an object of the Pokemon region class is calling, it is calling this attack function. So it knows when to call which function accordingly, and all of this is happening in the runtime. So this is also called method overriding, and this is also what we call runtime polymorphism. So these are the two types of polymorphism, one compile time and one runtime polymorphism, and that is the basic fundamentals. So that's it for this video. Thanks for watching. Bye bye. Hello folks, in this video we will learn about inheritance, which is one of the four essential object-oriented programming concepts. So inheritance allows one child class to inherit some attributes and methods from its parent class. So let's see this by an example. So here first of all I will create one class called Pokemon, and inside I will have a name, and I will also have one method. So let's write public void, and let's give the method as display name, and I simply want to display the Pokemon name here. So I will write name of this Pokemon is, and then the name. Now this is simple stuff, so we can also access the Pokemon from our main method. So I will create an object of Pokemon. Let's name the object as Eevee equals to new Pokemon, and I can assign the name. So let's write Eevee.name equals to Eevee, and I can also access our display name method. So Eevee.displayName, and let's see what the result is. So as expected, we are getting name of this Pokemon is Eevee. So now this is not inheritance. We will see what inheritance is now. So there are four kinds of inheritance, and the first kind we will check is called single level inheritance. So this is when one child class is inheriting something from its parent class. So here I will create another class. Let's name it Pokemon type, and I will write extends Pokemon. So what this means is this Pokemon type is an extension of Pokemon, and this becomes a child class of this parent Pokemon class. So whatever we have inside our parent, that is the string name and this function, we also have it inside our Pokemon type class. So here I can write another variable, let's call it type, and I will have another method over here. So let's write public void display name and type, and here I want to display both the name and type of the Pokemon. So I will write name, that is the Pokemon name, is a something type, whatever is that type Pokemon. Now let's try to access this from our main method. So I will create another object of Pokemon type. So let's name this object as Blastoise equals to new Pokemon type, and here I can access Blastoise.name, although the name is not defined inside the Pokemon type, it's defined inside the Pokemon, and this Pokemon type is a child class of this Pokemon, so I can also access the name. So let's write Blastoise.name equals to Blastoise, and then Blastoise.type equals to Blastoise is a water type Pokemon, so I'll write water, and I can also access both the method. So I can write display name, and I can also access display name and type. So now let's run the program and let's see what is the result. So as expected, we are getting name of this Pokemon is Eevee, which is coming from the above one, and then we are also getting name of this Pokemon is Blastoise, and Blastoise is a water type Pokemon. That means this single level inheritance, it works. And the next thing that we will see is called multi-level inheritance. So let's write multi-level inheritance. So this is when the child class itself has another grandchild class, and which is an extension of the child class itself. So let's write another class over here called secondary type extends my Pokemon type. So what this class is doing is it has access to both the Pokemon type class as well as the Pokemon class. So the Pokemon type is the immediate parent and the Pokemon is the grandparent, and the Pokemon has one child, that is the Pokemon type, and it also has one grandchild, and that is the secondary type. So this is how the secondary type will work. So this is what we call multi-level inheritance. And here let's write another variable, let's call it secondary type, and here I will have another function again. So public void, and let's give the function as display secondary type. Now a Pokemon can have secondary type or it may not have also. So let's say the Pokemon doesn't have, so I will simply write that name has no secondary type, that's it. And in case it has, I will do one method overloading here. So in the second one I will pass this string secondary type. So in the compile time it will understand that these two methods are different, and here there is a syntax error because we have to add one plus. And in the second case we will write name has a secondary type and then the type secondary type. So now in this case let's create another object of this class. So secondary type, let's name the object as Charizard equals to new secondary type, and now let's like assign the variables. So Charizard dot name equals to Charizard, then Charizard dot type equals to my fire type. Now we also have one secondary type, like Charizard is fire and flying type. So here let's do one thing, Charizard dot display name, and it will display the name as expected, Charizard dot display name and type, this will also be displaying accordingly, and then Charizard dot display secondary, let's call the first one. And now when I run this thing, what do we get? Charizard has no secondary type, so it is calling this one. And now let's give one secondary type and then do the same thing. So Charizard dot secondary type equals to flying, and now let's pass the accordingly function parameters. So I will write here Charizard dot secondary type. So now we are getting the results accordingly. Charizard has a secondary type line. So this is how multi-level inheritance works. So this is like the grandchild, and this is 2-level deep. Now the third kind of inheritance that we will see, and this is called hierarchical inheritance. And this is when like the Pokemon class will have 2 children. So right now it only has 1 child, and that has another child. So it has 1 child and 1 grandchild. So let's say it has 2 children or multiple. So in that case, that this is something that we call hierarchical inheritance. So let's create another class, and let's name this class as Pokemon Gen, that is generation, extends Pokemon. So this becomes one hierarchy. And here let's write another string of not string, we will write one int of gen, and we will simply print out our name and gen, because those are the only things we have access to. So public void display name and gen. So it will not be having access to these things, that is display secondary and this display name and type, because this is in parallel. Like only the child class will have access to the parent class elements. So these two are not directly related in that sense. So what can we do over here? So let's print out something. Let's print name is from gen and then the gen. And now let's create another object here, and let's name Pokemon Gen Celebi equals to new Pokemon Gen, and this Celebi will have access to the name. So let's name is Celebi, and it will also have access to the display name, and then this Celebi will have access to the gen. So Celebi is from generation 2, so it will also be having access to the display name and gen, but it is not really having access to the other things. So let's print out these things, and we have the same things, that is Celebi, name of the Pokemon is Celebi, and Celebi is from gen 2. Now let's forcefully try to access something from which is inside this Pokemon type. So let's try to display the name and type. Let's see if we can do something like that. So display name and type, and we have an error. So let's try to assign some type. So Celebi dot type equals to grass, and we have lots of errors, and hence we cannot do this. So let's remove it. And now lastly, the fourth kind of inheritance that we will see, and this is something we are already doing, is called hybrid inheritance. This is when the first 3 kinds of inheritance, that is the single level, multi-level and our hierarchical inheritance, we are doing together in a program, and this is something we are already doing in this program. So this is what hybrid inheritance is. There is nothing else to it. So that's it about inheritance in Java. However, there is one last kind of inheritance that we have not discussed, and we will not discuss in this video. We will discuss it in a separate video, and that is called multiple inheritance. And we have to introduce another keyword called interface for that. And this is something that happens when one child class will have 2 parent classes, and we have faced one problem that is called the diamond problem. This is something we will see in a different video about interfaces. So that's it for this video. Thanks for watching, and bye-bye. Hello folks, in this video we will learn about abstraction, which is one of the 4 essential object-oriented programming concepts. Now abstraction is a very cool concept, and we will see this by an example. So first of all, I'll create another class, and as usual I'll name the class Pokemon. Now the Pokemon will have one move, and it will also have one method. So let's name this method as attack, and I'll pass the move. Now I won't complete this method, and I will create 2 more Pokemon. So let's create Charizard extends Pokemon, and Charizard will also have access to the move and the method. So here I will write public void attack, and I'll do one method overriding, and I'll pass the move, and let me simply write Charizard use and whatever is the move. And now I will create another class, and let's create this class, let's name this class as Mewtwo, and the same thing, Mewtwo will have attack, and I'll write Mewtwo use and whatever is the attack. Now I'll come back to my main method, and here I will create one Charizard and one Mewtwo. So first of all, let me simply create Mewtwo, and let's name the object as Mewtwo equals to new Mewtwo. And now let me give one move, so Mewtwo.move equals to Shadow Ball, and then if I simply do Mewtwo.attack, and I'll pass my Mewtwo.move, what will happen? So let me write the program. So we are getting Mewtwo use Shadow Ball. Now we can do the same for Charizard. So let me just create one Charizard object, Charizard equals to new Charizard, and then we can simply do Charizard.move. Let's give the move as Flamethrower, and we can simply do now Charizard.attack, and we will pass the move Charizard.move. And now if I execute, we will get both. So we are getting Mewtwo use Shadow Ball and Charizard use Flamethrower. Now one thing to note here is, even if I write something over here, so let's write SOUT and then Pokemon attacked, will this be executed or not? And it won't be executed because the child class will override the method of the parent class. And in situations like this, we can simply make the class as an abstract class. So the abstract class Pokemon is only an idea which has a string move and an attack method, but this is not being implemented directly. It's being implemented by its children Charizard and Mewtwo. So this is the basic concept of abstraction. Now we have one attack method, but we can also make this method as abstract. So let me simply delete these things because this will not be implemented, and let's make this method as an abstract method. So the child classes will have access to these things, but these things cannot be implemented directly. Now there is also a way to implement the things inside the abstract class, but not directly, but there is a different way we can do this. And the first thing we can do is create one constructor, and inside let me write who is that Pokemon. And now if I run this thing, we will see that we actually are printing who is that Pokemon. And why is this happening? This is happening because whenever we are creating the Mewtwo and the Charizard object, these objects have access to the abstract class because it's the parent class, and then by default it's printing out the constructor. So similarly, inside the Charizard and Mewtwo, we can print few more things inside a constructor, and this is something that is called constructor chaining. So first of all, it will have access to the parent class constructor and then the child class. So let's write it's Charizard, and similarly also for the Mewtwo, let's simply print this thing, and here let's print its Mewtwo. And now let me run this program, and we have all these things. So who is that Pokemon? It's Mewtwo, then Mewtwo use Shadow Ball, and then who is that Pokemon? It's Charizard, then Charizard use Flamethrower. So this is how we can access whatever methods we are writing inside our abstract class also. And there is a different way to do this thing, and when we are writing a method with a different name. So let's say void description, and let's print out something. Let's print Pokemon means pocket monsters. And now both the Mewtwo and the Charizard will have access to this method because this method is coming from the parent class. So from Charizard dot we can execute the description. So now if I run this thing, and in the end we are getting Pokemon means pocket monsters. So this is how it is having access to the methods of the abstract class also. So this is one form of abstraction, but this is not pure abstraction because we can still do things inside our abstract class. So for pure abstraction, we use interfaces. And to do that, let me create another file called interfaces.java. And here we will see how we can actually deal with interfaces. So let me first create another method, public static void main string arguments, and here we will write few things. So first of all, in place of the abstract class, here we will create one interface called Pokemon, and as usual the Pokemon will have one void attack. And then we will create some child classes. So let's create one class of Tyranitar, and for interfaces we write implements. We don't extend it because interfaces are not really classes. It's similar to class, but here we only declare what are the things we are using. We are not really accessing it in any way. So implements Pokemon, and then inside I will have one string name, which is the name of the Pokemon, and a string move also, which is the move. And now I will write one method. So let me write public void attack, and I'll simply do, because I have access to the name and the move also, name, use, and then the move. That's it. And then let me simply copy this thing, and here in place of Tyranitar, let me create another class, Rayquaza. And now inside our main method, let me simply create one Tyranitar and one Rayquaza. So Tyranitar, and let's name the object as Tyranitar equals to new Tyranitar. Let me give the name equals to Tyranitar, and let me also give the move. Let's give the move Earthquake. And now we can try to access the attack. So Tyranitar dot attack, and we will get it. So let me simply execute this thing. So Tyranitar use Earthquake, and we can also create the Rayquaza, and everything will work like that. Now one more thing we should note is that inside our interface, anything we declare, that is in the final state. So that is in the final state, and that means this cannot be changed. So let's say, let me create one generation 2. So this will always be 2. Like we cannot really change this thing later inside our like Tyranitar class. So here if I try to do this thing, let's say Tyranitar dot gen equals to 3, it will throw one error. And what does it say? The static field Pokemon gen should be accessed in a static way. So this is actually static and final, so this cannot be changed. So let's try to write another method inside our like Tyranitar. Let's name this method as public void info, and inside what we can simply write is, let's say name is from gen, and then the gen. And now if I execute, what do we get? We get Tyranitar. Okay, we have to also execute it here. So Tyranitar dot info, and now if I execute, we are getting that Tyranitar is from gen 2, and which is correct. But now let's say I copy this thing inside the Rayquaza, and what will happen? So I have to create Rayquaza equals to new Rayquaza, and here let me write Rayquaza dot name equals to Rayquaza, then Rayquaza dot move. Let's give the move fly. I think we get it by default in Pokemon Emerald. And then let me simply try to execute Rayquaza dot attack and Rayquaza dot info, and we will be getting that Rayquaza is from generation 2. So there is no way we can change this to generation 3. So Rayquaza dot gen equals to 3, we cannot do this thing because this is in static and finally. And but for the general class, that is whenever we are doing an abstraction, here if we try to do this thing, this is actually possible. So here let me write one gen equals to 2. So this is not in final state. So here if I try to do, let's say Mewtwo dot gen equals to 1, we can actually do this thing. So this is the basic difference between abstraction and pure abstraction, and this is in general the basic concept of abstraction. So we are able to create an abstract class or an interface and we can define few concepts and variables, and then in the child classes we can implement these things. So that's it for this video, and you can also find all of this code in the GitHub repo link I have kept in the description below. So once again, thanks for watching, and bye bye. Hello folks, in this video we will learn about encapsulation. Encapsulation is one of the 4 object-oriented programming concepts where we can hide specific information inside a class. And to demonstrate that, I will create another class. I will name this class as secret, and inside I will declare a string username, and I will also give one value. So I will write #ketchum 10 because he is 10 years old. Now inside my main method, I can create an object of the secret class. I will name it small s secret equals to new secret, and I can simply print out the username. So sout secret.username, and if I run this program, I'll get #ketchum 10, and we are getting it. So there is no issues with that, but we will not be able to do this if I declare the username as private. Now there is an issue, and it's saying the field secret.username is not visible because this is private. But actually there is a way to access the username, and that is by declaring one public method. So I will write public string get username, and inside I want to return the username. So return username, and string is the return type. Now instead of trying to access the username directly, let me simply invoke the get username method, and we can actually get #ketchum 10 like this, and we are getting it. But what if we want to have a dynamic username? And we can also have it. So I will go to my script class, and I will cut my username, and I will create another function, public void, and I'll name this function as set username. I will also pass one string name as an argument, and inside I will simply assign the value of name to the username. Now inside my main method, what I'll do is I will simply do secret.setUsername, and I will pass my username, that is #ketchum 10, and then I have to call my getUsername method. So I will create one variable called secret username, and here I want to assign the value I'm getting from the getUsername method. So secret.getUsername. So I have my username stored inside my secret username. Now I can simply print out secret username, and we will get #ketchum 10. So we are getting #ketchum 10, and the first value we are getting is null because initially there is no value. So we can simply remove this part. So this is how we are actually getting the username that we are first setting, and then we are getting, although this is defined as a private. Now we can also define private methods. So let me define one method as private. So I'll write private void secret info, and inside let me simply print out that println this is the secret info. And now how I can actually get this method, and to get it we actually have to create another public method, and inside we have to execute this method. So public void get secret info, and now inside I will simply invoke my secret info method. Now this doesn't make much sense because anyway we have to call one public method to get the private method. So here what I can do is secret.get. We cannot call secret info, but we can call get secret info. Now if I simply run this function, I will first get #ketchum 10, and then I'm getting this is the secret info. So this is the basic concept of encapsulation in brief, that we can create lots of like private variables as well as methods, and then we have to define other public methods to access those private methods. And for setting up we also have to declare other public methods. So it's basically accessing private properties or methods using public methods. So this is the basic concept of encapsulation. So that's it for this video. Thanks for watching, and bye bye. If you like this video, make sure to like, share and subscribe, and you can also find more videos like this somewhere around here. So thanks for watching, and bye bye.